Hi students, today we'll start the discussion of one of the very important chapter in the second PUC or the intermediate second year or the class 12th. So that is the haloalkanes and haloarenes. It is one of the very important chapters in organic chemistry part of the syllabus. So that's why we'll discuss it today. So both the names haloalkanes and haloarenes composed of two words, so that we'll write now. Hello is the first word, hello, and second one is alkane and arenes. Alkanes and arenes. Hello is common in both the words. That's why we are studying. These are having this common substituent or common group. That's why we'll study in the same chapter. So when it comes to the hello means the halogen atoms. Halogen atoms. So halogen atoms are the 17th block elements. You all know which are one of the very much electronegative, very high electronegative elements. The halogen means salt generating. Halo means salt generating elements. So the halogen atoms are usually commonly represented by the letter X. So the common halogen elements and the natural halogen elements are fluorine, chlorine, bromine and iodine. These four are the natural halogen elements. So when it comes to the alkanes are, as you know, these are aliphatic hydrocarbons. Aliphatic hydrocarbons. And arenes are aromatic hydrocarbons. Aromatic hydrocarbons. So means benzene ring containing compounds. Aromatic hydrocarbons. So the name itself tells us haloalkanes and haloarenes. These are the halogen derivatives. The halogen derivatives of aliphatic and aromatic hydrocarbons. So when it comes to the definition of the haloalkanes and haloarenes, the definition, if you write the organic compounds which are halogen derivatives of aliphatic and aromatic hydrocarbons. This is one of the definitions of haloalkanes and haloarenes, the organic compounds which are the halogen derivatives of aliphatic and aromatic hydrocarbons. In general, we can also write another definition like how they are also prepared, how they are actually being seen. So that is the halogen derivatives both common aromatic and aliphatic. We'll just take the hydrocarbons. Halogen derivatives of hydrocarbons in which one or more hydrogen atoms are replaced with halogen atoms. They are forming haloalkanes and haloarenes. You can write halogen derivatives of hydrocarbons which are formed by replacing. Also you can write, that is a better one, in which the one or more hydrogen atom is replaced by X atom. That is okay, right? This is also one of the definition for haloalkanes and haloarenes. So these are so if you come to this definition, So for example, alkanes, CnH2n is the general structural formula for alkanes. If I replace one of the hydrogen, I'll make it 1, and if I put the EX, this becomes the general definition for haloalkanes and haloarenes. So haloalkanes especially. So this is about the haloalkanes and haloarenes. Now we need to know why we should study these compounds, because these are very much useful in day-to-day life. So that is why. So for example, yeah, chlorine derivatives. One of the chlorine composing or chlorine containing antibiotic, that is the chloramphenicol. Chloramphenicol is used as an antibiotic for the treatment of typhoid. So it is used in the treatment of typhoid. So one of the very important component has become. And again, one of the chlorine derivative used as another drug, anti-malarial. One of the anti-malarial drug, that is chloroquine, which is used in the treatment of, yeah, name, malarial. So it is used in the treatment of malarial disease, malaria. Okay. And one of the iodine use. Okay. So we in our body, a hormone thyroxine is produced from the thyroid gland, which is containing the iodine. So that deficiency of iodine in thyroxine hormone leads to the disorder, that is goiter. So goiter. So we need to have the balance of all these halogen atoms in the body, and fluorine is also required in the blood deficiencies. So that is why these halogen compounds, we'll discuss more application of these halogen compounds at the end of the chapter. So in the beginning, these are very much important in environment, in healthcare. So that is why we should study these compounds. Okay, this is about the haloalkanes and haloarenes. Now we'll discuss the classification of haloalkanes and haloarenes. Classification. When it comes to the classification of haloalkanes and haloarenes, so they are classified based on number of halogen atoms present in the compound, or number of halogen atoms are attached to the carbon atom in the compounds, or number of halogen atoms present along with the alkanes and arenes, or the number of halogen atoms replace the hydrogens. So based on the number of halogen atoms, the first class we can classify into is monohaloalkanes. So that is monohaloalkanes. Okay, and monohaloarenes. Okay, in general, if you both come together, it will be monohalohydrocarbons. Monohalohydrocarbons. Yeah. And when it comes to the second one, the second class, that is this mono means you already know it is one. So the definitely is the second one will be dihaloalkanes, and dihaloarenes are in general dihalohydrocarbons. Finally, instead of tri, tetra, penta, we'll just write polyhalohydrocarbons. Three and more than three halogen atoms, if they are present in the compound, They are known as polyhaloalkanes and polyhaloarenes are commonly polyhalohydrocarbons. Okay, these three are the classes of the haloalkanes and haloarenes. When it comes to the monohaloalkanes, the name itself tells us that they are containing only one halogen atoms. Only one halogen atoms. So I can write the I will write in the hydrocarbons. That is better. The hydrocarbons where one hydrogen atom is replaced with one halogen atom, one halogen atom, are known as monohalohydrocarbons. If you consider alkanes, it will be monohaloalkanes. If you consider aromatic compounds, then it will be monohaloarenes. So if you see an example, so if I write the general one first, yeah, CH3X, or generally we call it as RX. Okay. So here if you see the examples, CH3Cl, that is methyl chloride. Methyl chloride is the common name. And if you come to the IUPAC name, you all know the halogens are not considered as the main functional group. They are always considered as substituents. Hence, we have to write their names in the beginning as a prefix. So this one is chloromethane. The IUPAC name is chloromethane. So again, C2H5Br. Ethyl bromide is the common name. Ethyl bromide. Okay, and the IUPAC name will be bromoethane. Bromoethane. For example, haloarenes, monohaloarenes. So benzene ring. Here the chlorine is there. So this one is chlorobenzene. Chlorobenzene. So this is about monohaloalkanes and monohaloarenes. So here the only one hydrogen is replaced by this one halogen atom. So when it comes to the second class, that is dihaloalkanes and dihaloarenes, as name itself tells us that the hydrocarbons in which two hydrogen atoms are replaced with two halogen atoms. Okay, this also you can consider. Yeah. Now, yeah, generally these are usually, I can write like this: CH2X2. Not generally, it is a general structure, not for compulsory for all the compounds. It is not general formula, it is a general structure. Okay, if you see some examples, yeah, the same CH2Cl2, dichloromethane. If you write the position, it will be 1,1, because in methane only one carbon. Dichloromethane is the right answer. Okay, in aromatic example, if you consider, here chloro. Okay, 1 2 position if you consider, that will be 1 comma 2 dichlorobenzene. Dichlorobenzene. Yeah. Yeah, in case of dihaloalkanes, we have again further two subclasses in the case of alkanes especially. So well, let us see that. I'll write just here. I will take some very small topic, that is dihaloalkanes. Okay, the subclasses. There are two subclasses. Okay, the one is vicinal dihalides. Vicinal dihalides, because these have been asked in the exams most of the times, many of the times. That's why I'm writing it. I'm telling you. The second one is geminal dihalides. Vicinal and geminal dihalides. So vicinal means vicinal, in vicinity, nearby or neighboring. Okay. So if you consider this example, I'll write the example first, then you will come to the definition. Can differentiate between both of them. Yeah, CH3, CH, Cl, Cl. I say it as, not this one, this is geminal, CH2, CH2. This one, CH2Cl, CH2Cl, and here CH3, CH, Cl, Cl. Both are isomers. Okay, both are the same molecular formula, C2H4Cl2. Okay, what is the difference? Yeah, here the halogen atoms are attached to the adjacent or neighboring carbon atoms. Here both the halogen atoms in the dihalides, both the halogen atoms are attached to the same carbon. So if the halogen atoms are attached to the neighboring or adjacent carbons, they are known as vicinal dihalides. Vicinal dihalides. If the halogen atoms are attached to the same carbon, those are known as geminal geminal dihalides. These are been asked many times. So here what is? If they are attached to the adjacent carbons, adjacent carbon atoms. Here they are attached to the same carbon atom, same carbon atom. So you can write the definition, right? Complete. So the vicinal dihalides are the dihalides are the dihaloalkanes where both the halogen atoms are attached to the adjacent carbon atoms. Here in the case of halogen atoms attached to the adjacent carbon atoms. In the case of geminal dihalides, the dihaloalkanes in which both the halogen atoms are attached to the same carbon atom. Those are known as geminal dihalides, and these are commonly known. This name is known as vicinal, small v, vicinal dihalide. Okay, and this one is gem dihalide. Gem dihalide. So these are the subclasses of the dihaloalkanes, which are also very much important because these have been asked in many times in the exam. So otherwise they will give the examples. So this one is 1,2 dichloroethane. The UPSC name is 1, 2 dichloroethane. 1, 2 is gem, 1, 2 is vicinal, vis, and here 1, 1. Sorry, I'm not much comfortable to write at the below position portion. 1, 1 dichloroethane. Sometimes they may ask in your exam about the examples. So 1, 2 dichloroethane is an example of vicinal dihalide, and 1, 1 dichloroethane is an example of geminal dihalide. Okay, that is about the dihaloalkanes. When it comes to the polyhaloalkanes and polyhaloarenes, The names itself tells us that these are the hydrocarbons in which I'll write only the important portion, that is 3 or more hydrogen atoms are replaced with halogen atoms. Okay, the hydrocarbons in which 3 or more, this you should remember, 3 or more halogen atoms are replaced by the halogen atoms. So if you see an example, this one, 1 comma 2 comma 3, 3 is again come under polyhaloalkanes. It is 1 comma 2 comma 3 trichloropropane, like that in haloarenes, polyhaloarenes. So if you here Cl, 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 okay, same thing, 1 comma 2 comma 3 trichlorobenzene. These are about the polyhaloalkanes, the 3 classes. So based on the number of halogen atoms present in the compound, or based on the number of halogen atoms replace the hydrogen atoms, we have 3 classes, that is monohaloalkanes and monohaloarenes, dihaloalkanes and dihaloarenes, and polyhaloalkanes and polyhaloarenes. Here we can see trihaloalkanes, tetrahaloalkanes, pentahaloalkanes. The most common are tri, tetra in the case of haloalkanes. In the case of maximum, we can have hexa in the case of benzene rings. Those will become much unstable. So tri, tetra is, till that we can study the compounds. These are one of the stable compounds. We'll study in the further classes. But in this chapter, we are concentrating on the thorough study or in detail study of the monohaloalkanes. That is in the syllabus. So the study of monohaloalkanes is very much important in this chapter. So again, that's why we'll see the, now further it is classified, monohaloalkanes are further classified. So let us see the classification of these monohaloalkanes. The classification of monohaloalkanes. The monohaloalkanes are further classified based on the hybridization of carbon atom, okay, carbon atom attached to halogen atom, attached to the halogen atom. So based on the hybridization of carbon atom attached to the halogen atom, so we have further classified the monohaloalkanes into 2 types. Let us yeah, for example, here this is the carbon atom attached to the halogen atom. So depend upon this hybridization, the hybridization of this carbon atom, so we have classification. So if it has single bond, it will be sp3 hybridized. Further, if it has a double bond, it will become sp2 hybridized. So based on this hybridization, we have 2 classes. One is the haloalkanes containing sp3 hybridized carbon atom, or the monohaloalkanes containing sp2 hybridized carbon atoms. So that's why we simply compounds containing sp3 hybridized carbon atoms, compounds containing sp2 hybridized carbon atom. These are the 2 class will be in the monohaloalkanes based on their hybridization. So yeah, first one is, yeah, if I just wipe it up, The first one is compounds containing sp3 hybridized carbon atom. Okay. And the second one is compounds containing sp2 hybridized carbon atom. And these are again further classified into other three subclasses. Those are very important subclasses. Okay. Those are, so consider this is one Roman. This will be, the first one is alkyl halides. Alkyl halides. Actually, the correct term for haloalkanes. The correct term for haloalkanes. Alkyl halides. Okay, this is the one. And the second one is allylic halides. Allylic halides. And the third one is benzylic halides. Third one is benzylic halides. So these are the three subclasses in the compounds containing, or the monohaloalkanes containing sp3 hybridized carbon atoms. Okay, and all these three can again further classified based on the nature of the carbon atoms, whether that is the carbon atom, the sp3 hybridized carbon atom is primary, secondary, tertiary. So all three can be classified further. So for example, if I write on the alkyl halides, so three subclasses. The first one is primary alkyl halides. Primary alkyl halides. Secondary alkyl halides. And the third one is tertiary alkyl halides. It is based on the nature of the carbon, sp3 hybridized carbon, whether it is primary, secondary, or tertiary. There are again three classes. We can also classify in allylic also. It will be primary, secondary, tertiary allylic halides. In a benzylic halides also, we can again have a primary, secondary, tertiary alkyl halides. But once if you benzylic halides, so this is very important, the primary, secondary, and tertiary alkyl halides, because we need to know how it can be differentiated among these three. So that's why we need to know primary, secondary, tertiary. So these all again will come in the next chapters also. For example, alcohols, primary alcohols, secondary alcohols, tertiary alcohols. In the amines also, primary amines, tertiary, secondary amines. That's why in this chapter we come to know what is primary, secondary, and tertiary actually. And the first one is compounds containing sp3 hybridized carbon atom, and the second one will be the compounds containing sp2 hybridized carbon atom. sp2 hybridized carbon atom. The one is sp3 and the second one is sp2. You know, sp3 means carbon carbon, there will be carbon carbon sigma bond. In the case of sp2, there will be carbon carbon double bond. Even benzene ring also sp2 hybridized. So here in the case of compounds containing sp2 hybridized carbon atoms, we again have a two subclasses, two types actually. These are not classes, two types. So one is vinylic halides. Vinylic halides. The second one is aryl halides. Aryl halides. Okay, these are the two classes. The two types we have in the sp2 hybridized carbon containing haloalkanes. So aryl halides are nothing but haloarenes. Okay, aryl halides are haloarenes. Okay, so these two types, two classes, and based on the hybridization of the carbon atom, sp3, sp2. Okay, in sp3 again we have three classes: alkyl, allylic, benzylic. In sp2 we have vinylic, arylic. And here in the case of wherever we come to the sp3, we can have three types: primary, secondary, tertiary, whether it is in alkyl halides, allylic halides, or vinylic halides, sorry, benzylic halides. Okay, we will come to know what are these meaning. Okay, the compounds containing sp3 hybridized carbon atom. So if it is the carbon atom attached to the halogen atom, it must contain only the single bonds, only the single bonds. So then it will be sp3 hybridized carbon atom. So all these compounds will come under this class. In this one, we have the first one is alkyl halides. Okay, so these are the derivatives of alkanes. These are the actual derivatives of alkanes. Here the halogen atom is replacing one of the hydrogen atom, in the alkanes. For example, if you see here, the general uh, formula for the structural formula is, for alkane is CnH2n plus 2. And if I replace one hydrogen and if I write X, this is the general structural formula for all alkyl halides. Okay, all alkyl halides. These are alkanes in which the one hydrogen or the hydrogen, yeah, in which one hydrogen atom is replaced by halogen atom. Okay, so if I write an example, so general, for example, we call it as R alkyl halides, or if you can also write methane, halomethane. Examples: CH3Cl, that is chloromethane. The common name is methyl chloride. C2H5Cl, Br you can take, that is chloroethane. Okay, these all are the examples. Okay, yeah. And again, these alkyl halides are subclassified, as you already know, based on nature of carbon atom. Nature of carbon atom, that is primary alkyl halides. Okay, primary alkyl halides, secondary, tertiary. So the primary alkyl halide is, here the carbon should attached, the carbon atom attached to halogen atom. Okay, the carbon atom attached to or attached with the halogen atom, further attached to only one carbon, so those are known as primary alkyl halides. So the carbon atom attached to the halogen atom, further if it is attached to the only one carbon atom, that is considered as primary alkyl halides. For example, CH3, CH2, Cl. Here this is the halogen atom, this is the carbon attached to the halogen atom, which is an sp3, which is further attached to only one carbon atom. It is an example of primary alkyl halide. The name is chloroethane. Chloroethane. When it comes to the secondary alkyl halide, okay, then you can write now itself, the carbon atom attached to halogen atom if it is further attached to two carbon atoms. Further attached to two carbon atoms. Only one carbon, okay? Carbon. Two carbon atoms, two carbons. So that those are known as that carbon. Actually, the carbon attached to the halogen atom, if it attached to the two carbons, so such carbon is known as secondary carbon, and those alkyl halides are known as secondary alkyl halides. For example, here CH3, CH, CH3OH. This one is an example of, it is containing only one sorry, it's not OH, it is chlorine or bromine. You can take any one. Okay. So here halogen atom, this carbon is attached to the halogen atom. It is containing only single bonds. So it is sp3, and it is further attached to the two carbon atoms, 1 and 2. Okay. So this is an example of secondary alkyl halide. If you can write the name 1, 2, 3. This is 2-chloropropane. 2-chloropropane or isopropyl group, as you all know. It is isopropyl chloride also, you can call commonly. So here it is attached to the two carbon atoms. The carbon sp3 hybridized carbon, if it is further attached to two carbon, that is known as secondary carbon, and the whole compound is secondary halide, alkyl halide. The third one, that is tertiary alkyl halides. So I think, hope you can write now yourself. You can now write yourself the carbon atom attached to halogen atom if it is further attached to three carbon atoms. If it is further attached to three carbon atoms or three carbons, so that carbon is known as tertiary carbon, and those whole alkyl halide is known as tertiary alkyl halide. So if I write an example, CH3, C, CH3, CH3, okay, CH3. This is the carbon, right? Okay, this is the carbon attached to the halogen atom, which is having only single bonds, hence it is an sp3 hybridized carbon. It is further attached to the three carbon atoms. It is a tertiary carbon, and the whole compound will become tertiary alkyl halide. So the name of which it will be 1, 2, 3. This is substituent. So it is 2-methyl 2-chloropropane. 2-methyl 2-chloropropane, and its common name is very much important, that is 4 carbons, and it is a tertiary butyl chloride. The common name is tertiary butyl chloride. We'll see now in the further, we'll study some reactions of this compound, tertiary butyl chloride. So these are the three subclasses in the alkyl, allylic, and also in the benzylic. So depending upon the nature of the carbon atom, which is directly attached to the halogen atom. So the carbon atom, it is attached to the halogen atom. If it is further attached to one carbon, that is primary. If the carbon atom attached to the halogen atom attached to the two carbon, it is secondary. And the carbon atom attached to the halogen atom, if it is further attached to the three carbon, it is a tertiary alkyl halides. Okay. And in general, if you, for your remembrance, you should remember like this: CH2 will be primary. It will be primary, and if you can see anywhere, CH, it is a secondary, and C, it is a tertiary. Okay, this is the general thing you should remember. So this will become now primary alkyl halide, and this will be secondary alkyl halide, and this will be tertiary alkyl halide. So you need to remember CH2X, CHX, CX. Okay, that is easy for identification. CH2 primary, CH secondary, C is tertiary. Okay, so this is about the alkyl halides. Now we'll see the allylic halides. The second class in the compounds containing sp3 hybridized carbon atom is the second one, that is allylic halides. Okay, allylic halides. This is also asked in this exam for 2 marks. So that's what are allylic halides? Give an example. Allylic halides. Okay, here what is the allylic halides? The carbon atom, that is the sp3. Okay, and I can write like that also. The sp3 hybridized carbon atom. Okay, the sp3 hybridized carbon atom attached to halogen atom, or attached with halogen atom, attached to halogen atom. So this carbon atom, if it is linked with sp2 hybridized carbon, sp2 hybridized carbon atom of double bond, okay, the carbon attached to the halogen atom is sp3, but it further attached to the sp2 hybridized carbon atom. Such compounds are known as allylic halides. See here, CH3, CH2, double bond, CH2Cl. See here, this is the carbon attached to the halogen atom. It has only single bond, means it is sp3. It is sp3, and it is further attached to the next carbon is double bonded carbon, that is the sp2 hybridized carbon. Okay, the carbon attached to the halogen atom should be the sp3, but if it has to attach to the carbon, that is sp2 hybridized carbon of the double bond, or double bonded carbon atoms. So such compounds are known as allylic halides. This is commonly also known as allyl halide. So allyl, for example, we have chloride, that is allyl chloride. Okay, this is about the allylic halides. The next one is the third class, that is benzylic halides. So the name itself tells us benzylic means we must contain some benzene groups. So here the same thing, the sp3 hybridized carbon atom attached to the halogen atom is linked with sp2 hybridized carbon atom, of the benzene ring, or aromatic ring. So those are known as benzylic halides. So only the difference is allylic and benzylic. Here it will be aliphatic, here it is the aromatic. Yeah, it is having a sp3 of the sp2 carbon of the benzene ring, here the sp2 carbon of the double bond. So for example, yeah, see this compound, this is the carbon attached to the chlorine or halogen, which is an sp3 because it has only single bond. This is sp3, but it is further attached to the carbon of the benzene ring. This all benzene rings are All benzyl ring carbons are sp2 hybridized. So these compounds are known as benzylic compounds, and this compound is commonly known as benzyl chloride itself. Benzyl chloride. Okay, this is about the classification of compounds containing sp3 hybridized carbon atom. Now we'll see the sp2 hybridized carbon atoms. Compounds containing sp2 hybridized carbon atom. So if you see these halogens, we have two types already we have seen. The first one is vinylic halides. Vinylic halides. Here the same thing. The halogen atom is directly linked with sp2 hybridized carbon atom of double bond. So these are known as vinylic halides. Here the halogen atom is directly attached to the double bonded carbon. For example, CH2 CHCl. That is the common name with this compound is also vinyl chloride. As you know, all if it has a double bonded carbon, it will be definitely an sp2. So here the halogen atom is directly attached to the sp2 hybridized carbon of the double bond. So these are known as vinylic halides. In the second class, that is aryl halide. Now we can say the halogen atom is attached directly to the benzene ring. The hydrogen atom is attached or linked attached directly to benzene ring, the carbon of the benzene ring. You can say like that also. The halogen atom directly linked to the sp2 hybridized carbon of the benzene ring, also the same meaning. So here directly the X atom is directly attached to the benzene ring. So these are known as aryl halides, or commonly haloarenes. This is one of the important subtopic, haloalkanes and haloarenes. Okay, this is one of this one. And if you see an example, chlorobenzene. Yes, this is about the classification of haloalkanes and haloarenes. The classification is very much important, especially classification based on sp3 sp2 both, and number of based on the number of hybridization, based on the number of halogen atoms present in the compound, that is mono, di and poly. So and especially in the di, there are important things are in the dihalides, that is geminal and vicinal. Those may ask in your exam. And also the classification of the monohaloalkanes sp3 and sp2. Here they may ask about primary, secondary, tertiary, or allylic, benzylic, vinylic halides. So these usually do not ask halides because they are the same subtopics, haloarenes. So we'll discuss both in the next classes, haloalkanes and haloarenes. We'll discuss the nature of the bonds, nomenclature, preparations, and some reactions of these compounds in the further sessions of this chapter. This is the first session of the chapter. Please watch the videos completely and like the videos, share with your friends who are needed these things to know, and also subscribe to my channel and keep watching, keep supporting. Thank you.